Perfect. So over to so you can get the slides. Perfect. Hello, everyone. My name is Matthias Karlsson. I'm a partner and senior architect consultant here in Gothenburg, Sweden, and I'm also a Microsoft developer MVP, an active open source maintainer and contributor. I'm a father of 2 and husband of 1. I have a bit of a cold, but I'm fully caffeinated and ready to go. So the session. So over to Mark.
Hi, I'm Mark. I'm in Ireland at the moment. Yeah, my electricity probably went out. I've been a software developer, wrote my first code in 1977 or thereabouts. Got paid for it in 1987. I've been freelance for a fair amount of time since then, but these days I have a steady job with a company called GearSet as a software engineer. And the person you can't see, but who will be a large part of this, will be Katie, who is in the background on the chat, keeping an eye on everything, probably knows more about .NET than both of us put together, and will be able to hopefully answer your questions. It will be, sort of an interactive session, so feel free to drop messages in the chat, talk to each other, talk to Katie. If there's any questions for us, then Katie will make sure they get through to us. And this is what we're going to be doing today. Essentially, we're going to be going through one of the Microsoft Learn modules on the C# learning path. So we'll be talking to you about how to write C# console apps. This follows on from an earlier module, which just got you started with the general idea of C#. So we'll be taking you out of the browser and into Visual Studio Code, which we'll talk more about in a minute. And then we'll work through a guided project where Matthias will be coding something up for you, and in between times we'll be talking a bit about the C# concepts that we'll need to get through to the end of the module. So we'll be talking about sequences and decisions and methods and how to make sure that you can actually read your code and understand it when you come back to it sometime later. So if we want to switch over to Matthias's computer, then we'll get into the first bit.
Yeah, so essentially we're going to start from scratch here, and we're going to start by ensuring that we have Visual Studio Code installed. And the
what is Visual Studio Code, Matthias?
Oh, so, well, Visual Studio Code is essentially, it started as an editor, and now it's basically a full IDE with has certain extensions and everything for all kinds of things if you want to do all languages, but we're going to focus on the .NET side and C# side this now. So the easiest way to obtain it is to go to code.visualstudio.com. And you have the download button here, and it's available for both Mac, Linux, and Windows. So it's cross-platform, it's free, and you can just start. So let's start by downloading it. And we're doing this live on that machine, so we're doing it without any safety net or anything. So let's hope it works. So the installer will place it, and you'll also get some questions where we can actually say, like, if you want an icon on the desktop, you can also add to the context on Windows. So if you right click on something in the file explorer, you can actually you can open code from there if you want. So let's install it. And now we have like the classic thing where it will start to download things, and we'll hope to everything goes well. I used to know, like in the old days, I've been doing .NET since 2002. We got .NET on CDs. I don't know if anyone remembers those, but that's how we used to get things downloaded.
Yes, Visual Studio Code, if you've ever come across Visual Studio, which was the original product, you'll find that Visual Studio Code is a lot quicker to install. Yep. Visual Studio would be taking about 20 minutes at this stage, rather than 1 minute.
And here we can either launch directly, but we will finish now, and we will also ensure that we have the .NET bits installed. And .NET is nowadays a separate SDK, which before it used to either ship Visual Studio and part of Windows, but now you can easily go to get.net, and that will take you to a download page, and where you can download the bits you need to use .NET from the command line. We will go with the latest bits. You can see on this page we have .NET 6, which is the long-term support, and .NET 7, which is the like the short-term support. Soon we will have a .NET Conf, and then this will turn into 8. We'll have something to play with there. But essentially, you can download there. You can click on all downloads if you want for other platforms. But let's download it. And it's also
generally speaking, you'll always want the latest version, I think.
Yeah, you always want the latest if you're starting, because the version you start on is usually the one you end up to ship to production. So you want to start with as latest possible. So install, and this should be very quick.
The reason we're doing this, by the way, Visual Studio Code is an editor, and that allows you to do all sorts of different things. So you can do Python or JavaScript or all sorts of other things as well. So what we're doing for this is to install the .NET bit so we can do C# in Visual Studio Code.
Yeah, and it's fairly slimmed down by default, so it just has what you install, which is a good thing in my mind. And this was also like a CD before when you used to listen. So it's nice now we can download internet and get started pretty quickly while you're having a coffee. And it's always the last bit that takes the longest when you think the job. So now we installed both Visual Studio Code and the .NET CLI. So an easy way to verify that we have the .NET CLI installed is that we start a command line. And if we have the SDK installed, we can actually type .NET. And we do a version, for example. You can see that it's this version. Info will show us all the versions of .NET we have installed. So if you have both .NET 7 and 6, you will see both here installed, which is good. So now we have both the SDK installed and we have code installed. So we can, of course, verify that by seeing all apps that we have code here. You can also, though, do code and dot if you want to start code in the current folder if you're using a command line. And this is something you will see the first time you start code in a folder you haven't run before. You want to trust this folder because you essentially will develop and run code in a folder. So it will ask us. And of course, we're trustworthy people, so we will say that we trust. And it will choose some add-ins. But now we're going to do .NET development and things like that. But we can see what kind of things we have here in the window. We have the file explorer where we see files. We will have things like that. We also have the sidebar with things. We have a status bar. We can see things, and one of the editor and things. So it will have but first we will need to install extensions, and those we can find here, extensions. And the one we need to install for is called the dev kit for C#. So let's Google that up. There's loads of them, so let's do the C# dev kit. There it is.
This links up Visual Studio Code and the .NET SDK so that we can do all the C# things, essentially.
So this will add things that we go through. This will make it more capable and add the IDE part to the code editor. Perfect. So now it's installed. And one of the best features, if you don't know something, is to here you can actually search for anything in the IDE. And if you do the more than you can actually search for commands. So there's terminals, and so let's show the terminal. So actually you have a built-in terminal where you can run your commands directly in. So to create a new project with the .NET CLI, they actually have something called .NET New. There are several commands that you can see here with the .NET CLI would have everything for it. Start with .NET New. So if we clear. And when we .NET New, there's several templates, and for this session we will create a console application. So then we have enter console, and this will create a console application in the current folder, and it will create a project file, which is essentially just to tie everything together, and it will create program CS, which is the actual console application. And here you can see something that is fairly minimal, so you can get quickly up running. And this is something that makes it really easy. So to build your software, you just do .NET build, and this will actually compile the program, so you can then run it. You can see and we can do then .NET.
Run, finally.
And then we see, well, you can probably see that it outputs something similar to what we have here, which is really nice. So now we actually got the code, and what essentially the dev kit adds is that in your editor, which you have in the middle, you will add things like coloring, so you get nice and everything. It will also know that you're actually adding C#, so we'll add completion in this ID, and things like that. So it really makes it simpler. So that's now we're up and running. We have our Visual Studio Code installed. We have a project. We can see that we can compile. We know that we can actually run our software too.
So should we maybe go to the guided project that we're going to be working through?
Yeah, you can do that. So let's go to the starting point. Perfect. And it's so helpful because it will ask if you have something installed. But one of the things that you see here is that we now have the starter project installed and preview, which is now.
So yes, if you did the previous module, then I think you should recognize that as where we got up to last time, sort of thing.
Yeah.
So, yes. And you'll see there we've got a lot of names and a lot of numbers. Sophia 1, 2, 3, 4, 5, Andrew 1, 2, 3, 4, 5, and no doubt more further down. So yeah, I think the first thing we're going to be wanting to do is to tidy that up a bit. So if we switch back to the slides, we'll maybe just have a little bit of a chat about some things in C# that would make that a little easier to work with, and then we'll switch back to the code. So the first thing we're going to talk about here is something called arrays. So you probably came across in the first part that you have a certain types of what they call variable in C#. So you've got strings and integers and floating point numbers and a few other things. But what arrays do is allow you to store a whole list of those in one place. So in this case, you could have an order ID, which is a string. But if you want to have a whole list of order IDs, what you can do is you can say string and then those angled brackets. And you can define your variable to be a whole list of strings. So in this case, we're saying at the top line there that we want a list of strings. To be precise, we want a list of 3 strings.
Yeah.
So we can define that variable as a list of 3 strings, and then we can go in and create the actual entries for that by referring to each of them in, sort of by which number of the order they are. Now you will see there that that actually starts at 0. So, if you've not done much programming before, or if you programmed in something like BASIC, then you might think that would be 1, 2, 3. But in C# and in most other languages, in fact, we start at 0 because we like to think we're mathematicians.
Yeah.
So if you do something like that and actually try and set number 3, then that will actually break on you.
Yeah, and that you see because we have the first declaration there is that we've declared that we will only have 3 elements. So if it will actually try here to access the 4th element, which, well, it will be unhappy.
Exist. It will not be happy, and your code will, your program will finish and print you an error. You can also obviously then refer to those. So in this case, we're going to print out on the console, on the terminal, the first, second, and third values in there. So the first one is number 0, of course. The second one is number 1, and the third one is number 2. And that will print out all the order IDs. You can also change them after that. So if we change the one at index 0 there, then we'll find that when we print out the first element, then it's going to have that new value of F000 instead of the original value of A123. Now, obviously, if you've got a lot of these, then rather than typing order ID 0 equals A123, order ID is 1 equals B456, and so on and so on, so on, up to order ID is 99 or whatever it is, then you can actually do what's called an initializer. So if you look at the first line there, then we can just say, here is our order IDs, and give it as many entries there as we want, and it will automatically give us an array of the right size with all those entries in there. So that does exactly the same as we had in the previous slide there, but all in one line.
Yeah, and really convenient as you don't have to know how many, it will create an array with the amount of items you add in that initializer.
And since you don't necessarily know how many things are in your array, there is actually a thing there called .length. So in this case, our array is called order IDs. So if we want to say how many things we've got in there, we can say order IDs.length. So that would print out there are 3 orders to process. So just a quick recap there. So an array is, well, it's just another variable, but it holds a sequence or a list of related things all of the same type. You can't start counting from 0 when you want to pick items out of it, and the length property will tell you how many there are in there. Now, once you've got your list of things, obviously you're going to want to do things with the stuff in there. So there's a useful command called Foreach. So in this case, we've got 3 names there, which are in our names array. And what we can say is for each name in names. So we know that the things in there are strings. So we say that name is going to be a string. And then what was in turn, put that into your name variable. And in this case, it will print it out to the terminal. So that will go through 3 times, once for each of the elements in the array, and print them out. Now you can obviously extend that to do useful calculations. So in this case, we've got an inventory there with 5 inventory bins in it and a number of items in each bin. And what we can do then is to go through each of those bins, each of the items in those bins, and we can operate it there, so sum plus equals items there means add the number of items in that bin to the sum total. And the plus thing there is a shorthand way of saying add 1. So we can then go through that, add up the sum of items, count the number of bins, and in that case, we're printing out all the bins and then the total at the end. Once you've got your list of arrays there, list of items there, then you can use for each to go through it. You can set each of those values into a variable and then use that variable to go through in the body of what's called the code block, which is the thing after the for each. Yeah, question from the chat. Apparently, can you resize an array? There are things very much like arrays that you can resize. Now, an array, which is the simplest one, you can't. But if you're using, there are other things called lists, which are very similar to arrays, but which allow you to actually insert things in the middle and add things to the end and stuff like that. So, yeah, we're only touching on arrays here, but there are more things like arrays. So if you go off to the Microsoft Docs at docs.microsoft.com, then you can go and find more types of what's called enumerables.
Yeah, if you look for collections, you will find a lot of collections because there are some very specific for specific needs. But arrays are the basic things, and those are essentially, if you need to resize it, you will need to create a new array and copy to it or something. But there are other more convenient classes for that. But we will start with arrays today.
Right, so having learned that,
let's go to some code. So if you go to the demo code, Laura. Perfect. So here we see that we have we don't use arrays currently. So we have all these variables separately, and that makes it, well, inconvenient. So are we going to start by converting these to arrays? And that will be, so if we arrays, we can see are defined by the brackets. And let's see do you have a good name here, Mark? It's important to name things.
Sophia scores, I suppose.
Yeah. So let's do Sophia scores. And we will create, and here we can see the benefit of having an ID that will help us. People know that we are going to create something like that. And if we're going to do the first way, we'll see that we have 5 elements. Then we will do the size of 5. And we can then do the Sophia scores. And we can do 0 equals all these kinds of things. But I mean, in a way, we often programmers way too lazy to do it, but essentially that's what we could do. We can also do, as we talked in there, we can just do the collection initializer. Let's do where we do the 90. Oh, this is live, and we're factoring it as well. And 98 and 100. And this way we can see we have all these nice and tidy here. Let's not forget about Andrew. So let's do Andrew scores. And you got to 92, 89. You don't want to cheat, a 90. You can see how we tidy up here to have more nice syntax. And then we have Emma. And I mean, one good thing to know is actually you can actually do var, which yeah, that's better to continue this race.
Yes, var is a useful one if you can easily tell what it is, because in this case it's we've created a new list of integers, so we actually know that this is an integer array. So
and that's what, if you read, it's called type inference. Yeah. So
as long as C# can work out what it is from the right hand side, then you don't need to tell it on the left hand side.
Which is a nice feature there.
There's a question here. How do C# arrays differ from JavaScript arrays?
I would say the biggest thing is that they're strongly typed in general.
Yeah, so in a JavaScript array, and we'll not move into TypeScript at this point, but in a JavaScript array, you can put anything you want in there. So you can put numbers and strings and booleans and anything you want in there. Also, a JavaScript array does have things like push and pop to allow you to put things on the end and remove them. So yes, it's resizable.
It's more like a C# list in that way, that you can actually insert and change and mutate it in that way. Perfect. Let's see how we. So now we are our nice arrays.
I think you're missing a semicolon.
We always are, and that's the difference by JavaScript and C# too. So it's important.
The compiler would have told us.
It would have told us. And here we see before, when we had the sums, we essentially just added these variables together. In the slides, we added a simple that we actually could do for loops or for each loops to this. So we're going to try instead to do, so if we go to have Sophia's course.
Plus equals thing that adds numbers to other numbers.
Yeah, and this is essentially the same as if we have written, and you will find programmers like to write as little code as possible, but essentially that's the same as doing Sophia equals. And we have Andrew. And we need the S, because otherwise it won't compile. And we also see that I named them wrong. So this is the sum. Let's do that. And one difference is usually like C# would tell us if we did something wrong here, as it's strongly typed. So I have Andrew, Emma. Let's add Emma.
And Logan was the other one.
Yeah. We don't want to get another year with Logan. So let's go to Logan. So essentially, these loops are now done something generic, so we can remove these sums, hopefully. So we have to go to the terminal. We can actually see if our code, if we've done anything wrong. So that was the .NET build. We will actually build our code. And it's always nice to, like, you never get it right the first time, but we didn't. So let's see here, we got errors. And it will actually give you the line and error. And
Andrew's score instead of Andrew's sum, I think.
Exactly. So that's something where Java script probably would let you just go forward. And you will get an error later. This will actually give you an error. And that's one thing to be important here, like if you see a little star like this box, it's not saved yet, so you have to Control S. So let's build our code. It actually succeeded. So if we do a .NET, nice. So let's, if we just hide. So now we can see how we've gone from multiple variables to have something that's more generic and sum them together. What do you think we should do next, Mark?
Well, I think we should do something with those scores and, you know, maybe decide what we're going to do with them. So yeah, should we pop back to the slides for a minute? And we'll start talking about how to make decisions in your code. So the first thing we're going to talk about here is the if statement. And that's pretty much what it says, like if something is true, then do something. So in this case, you know, we've got a string there, which is this message, and we want to say if the message contains the word fox, then we're going to print out what does the fox say. Now, there's a little thing, you know, you might have heard me mention Booleans earlier. That message.contains thing is actually what's called a Boolean, which is a mathematical term that computer scientists stole, and all it actually means is something that can be either true or false. So what we're actually saying there in the if statement is if the thing we're checking is true, then we'll do the stuff in the code block afterwards. Now we can do various things to get those trues and falses. So in this particular case, you know, we've got a little bit of code at the top there which rolls as a random number on a dice. And in that case, we're going to say if the roll, if the number that we rolled is greater than 3, then we print out you rolled 4 or more. And similarly, we can do things like that. So we can say if the roll is less than or equal to 4, you can say well, you rolled 4 or less. You can also do slightly more complicated things. So if we want to check in this case whether we rolled 2 of a kind, so if 2 of the dice match. So you can see there, you know, we're on the if statement here, we've got if roll 1 equals roll 2, and then you've got those 2 vertical bars there, and that's the way that C# says or. So, you know, if you read that yourself, you say if roll 1 equals roll 2, so dice 1 equals dice 2, or roll 2 equals roll 3, or roll 1 equals roll 3, then we know that 2 of the dice were the same, and in this case, you know, we say you rolled a double, and we get 2 extra points for doing that. So in that case, you know, we've got 3 different things there we're checking just to see that, you know, whether any combinations of dice are actually the same. On the other side, if we want to check if we've rolled 3 of the same, then we can say if roll 1 equals roll 2, and as you probably guessed, the 2 ampersands then and.
So there we can see if you're on a roll or not.
If 1 equals roll 2, must be the same. So we've rolled a triple, and in this case, we get. You know, deciding whether to do something or not. Booleans, which return true or false, and we've got those 2 things, the double ampersand and the double pipe symbol, as it's called, which say, you know, which mean that you can check 2 things and say, and in which case they both have to be true, or which means that at least one of them has to be true. If we want to decide more than one thing, now, you know, here we're just using 2 if statements. So we can say if the total is greater than or equal to 15, you win. If the total is less than 15, then you lose. But what you can do there is, you know, basically one of those 2 things is always the case. So you can change that to just else. So what that will do is say, if total is greater than or equal to 15, and if that's true, then you win. If anything else is the case, then you lose. And you can go one further than that and have several different things that you're checking. So in this case, we're going to get a prize depending on how good our total is. So in this case, we say if the total is greater than or equal to 16, then you win a new car. Otherwise, you do an else if. You say otherwise, if the total is greater than or equal to 10, then you win a laptop. And if you did win the car or the laptop, then you win a kitten as a booby prize.
We all like kittens.
Oh, kittens are lovely, but
Yeah.
yes, in my experience, they cost more than cars. So yes, the combination of those ifs and elses mean that you can choose which of several different things to do in each case, depending on what's true and what's false. Multiple exclusive conditions means that you're only ever going to do one of those things, and you don't have to do the else, but if you do, it always has to come at the end. Right, so I'll go back to Matthias, and we'll hopefully use a little bit of that to make our code a bit more interesting.
Perfect. So what should we do? Well, let's do some like if statement. Like currently we have all these students hard-coded here. So we could start with having an array with the students' names. Could be a good starting. So we have something to if on. So let's do, in that case, we have a string array is where we can have a set of strings. And so let's do something called student names, for example. And we have Sophia, Andrew, and we have Emma. And essentially Logan. And this is what, there's it's a string. So, and if you see here, like, well, we can also make this a bit more readable by having some clear so you can all see what we're typing. So let's see if we could do something where we iterate over this. And iterate essentially we will do a for each. So let's simplify
Iterate
this.
is just a term that means going through all the things in a list or an array.
So if we want to, for example, now we have all these sums. So we want to like a total. Then we could do for each. We have our students. And let's do some so if we have our student Sophia, then add. So do we create see if we can see something. We can just see if this works. So first, because then we should have
folder.
Yeah. So if we do a .NET run here, do we get?
Yeah, you've got two S's in console, I think.
Yeah, it's so picky, which is good. This is actually by design. If you don't, if you get it wrong,
one day the AI will know all this, and we won't have to worry.
Yeah, well, actually, you have if you fixed wheel error. Let's see. You can see in line 11. So let's see in line 11. Well, I missed some code. So that's something nice with precompiled language. And did we get an Sophia? No.
the eagle-eyed amongst you will notice that Matthias is now just starting to type .NET run, because in fact, it's clever enough to know that if the files have changed, it needs to do a .NET build before it does the run.
Yeah.
So we'll actually do that for you.
So here we got probably did I type something wrong? And we can see that, let's see.
There's a quick question here. On that line 59 there, somebody's asking, can you replace Sophia with a string variable? To which the short answer is yes, you can. In this case, we put in a specific name, but if we wanted to get somebody to actually specify a student name, we could do a console.readline student name and put that in there instead. And yes, a variable could go in there instead.
Yeah, and actually there's a good thing if you're a full ID. If you press F5, you can actually debug your code.
Oh, you're stepping ahead a module or two here.
Yeah, so I won't do that, but we're going to do run now. So let's see, we can
everybody should come back for, of course.
Yeah. So let's see if I got anything wrong or if I don't. Oh, it printed Sophia. So actually it works. So let's continue. So in that case, we will iterate, we will only print Sophia because we only had an if statement for Sophia. And we also we know that it can only be one student, so then we can have the else if. So let's do the student. And then we had Andrew. And this is also the code block, which is the scope where things run between. What more students do we have? We had Emma. And for the sake of argument, if we know we have gone through all, we could do an else. And it should be Logan. But we want things to be correct, so we'll also check for Logan. Yeah.
I want to just hide the terminal quickly there so that we can see a bit more of the code.
Let's do that. We can always do, it's actually easy to just go here. So the full screen. So we'll have this, which means we could simplify because we have copy-paste code here. And so instead of, wouldn't it be nice if we can reuse some of the scores or things like that? So we can do scoping. And one thing is if we declare, we can actually declare variables within this, then it will only be accessible within this here.
Just in that code block there.
So it's good to know if you can't access something, you can only access within this scope here. So, well, if we're going to do the student score, let's do an array for that. So to make it easy, let's do just like a helper. And then we can do, if we're in with Sophia, we know that student scores are Sophia's student scores. If we're here, we can know it's Andrew's. And if we can guess but this is Emma, of course, and Logan. Oh. Let's get yeah. So now we can see that we can, based on who it is, we can actually fetch out and have a common variable we can reuse. So let's do calculate the current score. And let's see. So if oh, it's back. Perfect. Machine displayed a bit there. If we want something like, instead of having all this, we can actually do some reusable things. So
here we're actually getting a for each inside another for each. So we're going through one list of things, and then
so now we can actually nest our
another list of things.
Yeah. So for that we can do the number of. So if we're going to add that, let's do let's declare a variable first. So do the and call it fat fingering over. So do score. I can call it sum, and we can just do perfect.
Sometimes autocomplete is really helpful. Sometimes it just gets in them.
And this way we can, as we did before, here we wrote the name. So let's also get the grade. And the grade, we had the formula here. So for the, oh, we don't have the, they actually did the grade hardcoded here. So I think the current assignments, then the score. So score sum and current score.
You print out the student's name and their score.
Yeah. So let's calculate. So this is the sum. So sum, and then we have score. We need to. So the score, as we said before, we also need the number of assignments. If we can type. So we know the score was the student sum. And divided by the number of assignments. And here we had the names hard-coded, and now we can actually do the student name. and we had little nice formatting here, which a tab, and this is actually something called escape in C#. So I will insert a tab and the score. So let's try if that works. Otherwise, it will scream at us. It did. So online, let's see here. Valid line 1. Oh. This was hard-coded before, so it works all in here. So then we just need where did I go wrong? Now I need my pipeline. Let's see.
Is it first area?
Let's see. Line 8. Oh, sorry. Or
where are we?
oh, did I? And the Foreach. Let's see. It's
line 81.
81. So let's see. Oh.
Right. You can't tell it bar and int. You have to give it one or the other.
And then on line 89. So let's do 89.
You've forgotten the clinical one. Again.
Yeah. That's what happens when you do the live. 75.
And you've got students somewhere instead of students.
Yeah. So this was the variable. Let's just see if I.
On line 83 there, you've got.
That's perfect. I have someone.
Students, you missed a T.
It's a. That's one. Oh, let's see. And we have on 81. Do you see something else I missed?
What was the error?
75. Oh,
75 can't turn decimals into arrays.
Yeah, and that's why we had the casting is called. And this was, yeah, and this is one ID you can see, and this is, let's see what's happening. And on 75. Oh,
Logan scores, you're not Logan score.
That's the, let's see. And we have on line 81. Let's see what got that wrong. Let's see. Oh, we already have a score.
Probably delete the decimal score there, can't you?
Yeah. Let's see if it's. Let's. Oh, it's unassigned. Problem. Oh, it's just.
Yes, you're using it in two different ways. You've got one on line 81 and you've got one further down.
Yeah.
Yeah, if you go back to line 81 there, you can see there you've got a score there, and then you've got a score on line 87 as well, which is.
I see. So that's scoping. So let's call this one student score. So, and should this make it happy? And then we should need to declare this one. Or did I move it outside? Yeah. Let's see if it's happy. It's very small here. So, outside scope.
There's a question in here, why are we writing decimal before Sophia sum? Decimals are not, decimals are floating point numbers, so like, sort of something point something. So in a few of these places where we're doing divisions to work out the score, then we're going to need to use decimals rather than integers. Sometimes if you've got something that is an integer, then you need to turn it into a decimal before you do the division, so that it knows that it needs to do a floating point arithmetic rather than integer arithmetic.
So,
cast when you put a brackets decimal or something like that in brackets before something, it means turn it into something else.
This is we score here. That's why it's so. We're mixing code, so let's just remove this. That's why it complains. We already have score here. So yeah. So now we only have one error left, and that's 57, and that's. Let's see where it's at. On the side.
Yeah, it's because.
Yeah, that's because we didn't assign this. So let's do. Now it will be happy. Yeah.
Something's already running. Is it running?
No, it's not. There's something used in the process. Let's see. Let's see. When it fails, let's reopen this one. I think it's. If all fails, you'll start again. Yeah, now builds. And so now we're in line. Yes. So now so now we can get back to actually running this code. And we can see that we have simplified this by now we have the same code. We also want to add the grade was hard-coded before, but just let's add some, so we base it of something. So we want to add a grade too.
So before we get onto the grades, we'll just take a quick break back to the slides.
Yep.
Yeah, I just thought I'd go through what's called methods here. So, you've seen, we use console.writeLine a lot, and in some of the example code we were using earlier, you saw that we were using this thing called dice, dice.next to roll the dice. Now, these things where you've got something, they're part of what's called the .NET framework. So they are all the useful things that .NET gives you to, do calculations or talk to things or sort of use the terminal or what have you. And so usually you say the thing you're going to use, so console in this case, and then the thing you're going to do with it, so write line in this case, which means output a line to the console. Now, the basic thing to know here is that there are two different sorts of ways you can do this. There's the stateless way and the stateful way. The stateless way is when, in this case, the console doesn't need to remember anything, so you can just go straight to console.writeLine. The stateful way is when the thing does need to remember something. So in this case, in the second case, we've got the thing called random, but we need to create a specific version of random so that we get the right set of numbers for however that's been set up, so that we can, in the case of the random, it needs to remember internally what seed it's got and things like that, so that it makes sure that it gets a good set of random numbers. So in the stateless case, you can just say console.writeLine. In the stateful way, you actually have to say new random. So you could have said new console. In this case, you're saying new random, and that creates you a specific version of the random called dice in this case, which is essentially another variable, just a variable which is a random object. And then you can say dice.next. If you're, when you're doing these things, go off to docs.microsoft.com and it will tell you which version of this you want to use, depending on nothing, which essentially do very little. You can also have inputs and outputs to these things. So in this case, we've got the dice.next there. We've got an input, which is two numbers, 1 and 7. And then you've got an output, which is the thing that goes into the roll variable there. So, that's essentially saying I want a number between, which is greater than or equal to 1 and less than 7. So a number from 1 to 6, in fact. And then that's going to go into my integer called roll, and then we can write out the roll, which is another case in console.writeLine of having an input when, this time the input is roll. And there's a concept called overloading, which means that you can actually, if a method like next is suitably defined, then you can pass in different combinations of parameters. So in the case of next there, you can either pass in no parameters or no inputs, or you can pass in 1, or you can pass in 2. And in theory, you could also define one which passed in a string or an array of strings or anything you want. So again, you go off to the Microsoft documentation and it will tell you what the things you can pass in there and what comes out as an output. Yes, so there is a suggestion from the chat. It is not obvious to beginner why random needs state. It's because it needs what's called a seed, so to get a particular set of random numbers. Because sometimes you want your random numbers to be repeatable, but
often you don't. Actually. And I mean, often these stateful methods, or if you Google at the docs, it will call they're static methods, and also others called instant methods. You might also see them mentioned as.
But yeah, so .NET framework, or ones that you define yourself later in the classes, then you say the name of the class dot the name of the method and then brackets after it. You may have to do and create a new one if it's a stateful one. You can pass in as many parameters as you want from 0 upwards, potentially with several different combinations. So always go and check the docs, and some of them will also return a value. Quite a lot of them will return a value, so that you can do something useful with whatever it was that it was doing. Anyway, back to the code, and we'll try and work out those grades.
Yeah. So the student wants some grades. So back to the demo, and perfect. So like we saw before, the grades were hard-coded here, but we want to have some conditional, like business logic here to have what they are. So first we want to convert the grades to a letter, and that should probably be a string is usually what we use there. So like if you do a variable, so we call like current, like a student letter grade could be a good name. And so say if they have greater than 97 as the average there, so then would be if score greater equals 97, then the student letter grade, that's an A+.
Definitely sounds like an A+ to me.
Yeah. And
here we're going to do it.
So say for a 93, if that would be sorry, my keyboard switched to a different layout. So perfect. So if it's 93, that would be an A. So then we can say that the student is an A. And what would be a good next grade, Mark?
90.
90 could be good. Yeah.
For an A-.
If we say it's a 90, a 90 would be probably like an A- or something like that.
Yeah.
So let's do a student letter grade equals A-. And what would be a B+? I would say like 87 or something like that.
87, 83, and 80 for the Bs.
Yeah. So a B+ would have something like, let's see here. 83.
Yeah, 87, 83, and 80, I think, for the Bs, and then
would be perfect. So 83 would be a B, and 80 would be a B-. And we will have, of course, we will have a C+. I'll just copy these and change the B's to C's. C, and what would be a good C? Well,
77, 73, and 70.
Yeah, perfect. It looks like we go 10 down each time.
Yeah.
And
it sounds like
also have some D's. There's almost some logic to the madness here. Let's see. So we'll have our D's.
D's with 60.
So that's almost like 10 below. Perfect.
I think after that you're failing, aren't you?
Yeah, you're probably. I will give you an F for anything below that. So that would be an else. So the fallback, if you don't have anything else, do an F. And then we could add to our nice output here. We add another tab and our letter grade. So let's run this and see if it compiles. You never know. So we'll build our code. And as I said before, you can just do .run, but that will implicitly do a build and then a run. So now we can see that we actually get the same output here as we did with the hard-coded stuff. And we want the nice, so we can always remove this copy-pasted code. And we also want this nice. And to get that before, we just added before our for loop, which is way up here somewhere. Yeah, perfect. Let's run that, and run will implicitly build, and so we got it. Perfect. Cool.
Is there anything else to do now?
What should we go next? Well, I think we're pretty good. We have converted all our. We had multiple ints that now is in nice variables. We, instead of having the student names hard-coded, we have them in an array we can each. So we have a nested for each loop here. We'll go for each student. Then we check which students they have and pick out their scores. We then, in one place, instead of have the copy-pasted, calculated their grade and letter, and output that for each student. So we have had our so-called business logic. This could be if you have orders or something like that is similar, but here we have a multiple if, an if statement for that. I'm fairly happy. We can probably sell this. This is a great application now.
Oh yeah, sell this to all the universities now.
Yeah, because now I have a grading system.
Right, okay, shall we go back to the slides, or do you want to do anything else in the code?
We can go back to the slides.
Okay. Right, so last bit of the slides here is really just about, you'll have noticed, sort of, the way the code has been set out before. Just talking a bit about readability. So here we have a perfectly valid C# program. Matthias, have you got any idea? Can you tell from reading that what it does?
Well, it's really hard to read, but because everything is basically on 2 lines. So like if someone sent me this code, I'll send it back to them.
So
and here's where we talk like
that's your fault.
It's all fault. Probably when someone blame it's yourself. And
Okay.
here why it's like important to actually what we call whitespace. And what is whitespace? Well, the whitespace is either a new line or spaces to make the code more readable.
Yeah, so here we are. Here's something with a bit of white space. So what we've done there, so that first one, like I say, was perfectly valid code because C# really doesn't care how many spaces or blank lines or whatever you put in there. So this is exactly the same code, just with line breaks and spaces in there. But already it's a lot easier to read. So we put spaces in between things like the divide signs and the equals and the greater thans, just so it's easier to split out the individual parts of the code. And also we put a little bit of white space there before console.writeLine, just so it's easier to see in that if statement which bit is the code block and what are the things that if statement is going to run.
Yeah.
No, so that makes it a bit easier to actually just see what the code is. But obviously, so it's not particularly clear what the rest of it's doing, because all we've got there is A's, B's, and C's. So the next thing for readability is always to make sure that the variables that you're using have sensible names. So in this particular case, A is actually miles, B is hours, and C is speed. So we can see that, we're saying that there are 60 miles, 2 hours, and then we're saying if the speed is greater than 30, then you're going too fast.
Yeah. And this essentially will get your the cognitive load to read the code. Sometimes it's faster to write A, B, and C, but if you come back to that code and will read it again, you will have no idea what it's doing. So this makes it a lot more readable. The trick is
always to think that either you are going to come back to this in 6 months and you will need to know what's going on, or that really unpleasant programmer, that's going to be hired soon, that will be really cruel to you, is going to see this code and come around to you and ask what the hell's going on. So basically, just insurance for the future.
Yeah, and I mean the thing where we do that, you see the console write line is indented. It makes also which when you had this like we had with the students when we had a for each in a for each, it makes it easy to know which scope you're in.
Yeah, so if you're doing loops inside loops or ifs inside ifs, then you can then much more easily see where that sort of code blocking and things are happening.
Yeah.
And the final thing I'm going to mention here is comments. So you've probably seen those scattered around as we've been going through, but it's always worth, where anything might not be clear to somebody just from reading the code, put in a comment to explain. Now, I probably over commented that just for the sake of the example, but certainly anywhere where you're doing something which you had to work out how to do it, write down why you've done it that way. I mean, miles equals 60, you don't necessarily need to put a comment in for, because it's fairly obvious what that's doing. And speed equals miles divided by hours, you don't necessarily need to comment, but some people might not know that that's how you work out a speed, so you might want to put a comment in there. But yeah, as a general rule, if you had to think about a particular piece of code, put in a comment to explain what you ended up doing, and it'll be a lot easier to come back to.
Yeah, and also like if one line of code doesn't work, you can actually comment it out and try. That's a good practice.
You can actually take those double slashes which start a comment and actually use those to get rid of code you don't want for a minute. Particularly useful when you're debugging and you want to see what happens if something isn't there. Recap of that: use whitespace, as it's called, just space in general, and empty lines to improve the readability. Empty lines are best put around what they call phrases of code. So in other words, lines of code that either look the same or work together. So where you're assigning several things at the same time, or where you're doing a small calculation that only takes 2 or 3 lines. Put indentation inside a code block, so you put a few spaces at the start to move it to the right. Definitely always use meaningful variable names, and do put code comments in there where it's going to make sense to tell you about the problems that you're solving and how you're solving them.
Yeah, especially if something doesn't look right, it's good to enter like a comment why it looks like it there, or if it's something more complex.
Okay, so that's pretty much it. If anybody has any final questions, do feel to drop them in the chat now, because we'll go to Q&A in a minute. But just quickly, just to summarize what we did there. We started off with arrays. So we talked about how to store lists of variables, so lists of numbers or integers or whatever. We talked about Foreach, the Foreach statement, which allows you to go through all the things in your list and do the same thing to each of them. Then we talked about if statements, which is where you decide how to do something. So when you're going through, in your Foreach loop, for instance, you're deciding for each of those things what you should do with it. Also else and else if and else, so that you can decide between several different things to do. And then we talked about methods, and finally, which is essentially console.writeLine and things, so all the stuff in the framework that allows you to do useful things. And then finally, we talked about the readability of code, so putting in white space and putting in comments and using proper variable names. So do we have any questions in the chat?
And also talk about nesting, the part you can nest code, you can nest your if statements and things like that. So it's really,
so nesting means putting one thing inside another. So you can have an if statement inside another if statement, or you can have a Foreach inside another Foreach, or you can have an if inside a Foreach quite often. So yes, in those code blocks, you can put code blocks inside code blocks. If we have no further questions other than what we handled on the way through, then I think that's pretty much us. So just a couple of things there. So that's the link off to the actual learn module. So I would strongly suggest going off and working your way through that, because we've done some of it, but not in the full detail because we're time limited, and you'll get a chance to actually do the coding yourself and work through all the problems that poor old Matthias was having to deal with there when it didn't quite work. So it's always good to get yourself a bit of real world experience of sorting out, finding problems and sorting them out. So yeah, go off there, and then don't also forget, once you've finished all the Learn modules, to take the C# exam, free code camp.
And that will get you a certification, so you can share on LinkedIn or something like that. So it's nice.
I think you get a nice little badge and certificate probably at the end, which you can show to everybody and say, I'm a C# programmer.
Yeah,
Give me a job.
like badges.
Or give me a better job.
Yeah.
Okay, well, that's everything I think from us. So thank you very much for coming along, and
Thank you for joining.
Hope you enjoy the next module.